Okay, we should be live now.
Let's wait. It looks like it's not started yet.
Okay, we should be live now. Hi, everybody. Welcome to another session from PyLadies Amsterdam. We are on a mission to promote, educate, and advance a diverse Python community through outreach, education, conferences, events, and social gatherings. I am Nancy, and also hosting today is Aliona. Tonight in our session, we have Cynthia Liem, who is an associate professor at Delft University of Technology, a professional concert pianist, and a current member of the Dutch Young Academy. Cynthia will be presenting an introduction to communicating about your models. If you have any questions, please post on the YouTube chat. Don't shy away and ask your questions. Cynthia, whenever you're ready, you can go ahead.
Thank you very much. Good evening to everyone. Yeah, we promised an interactive session. The hope had been that we could meet in person, but sadly, I have to do it in this form where there is Jitsi and YouTube between me and you at home. So we're going to try it this way. First of all, I'd like actually to start with an interactive exercise. And let me make sure, I think now you can see me too. Let's first go to Mentimeter. I think most of you might know it. You can do that on a phone or you can do it on your browser. Go to menti.com, enter this code, and think of a moment when you had to communicate data science or machine learning work to someone who is not in your role. And as you do that, let me then click on. What was the role of the person that you had to communicate with? Can you share some of that? And hopefully we'll see that appearing out here.
And there's also could be some delay between the stream. So at least let's wait 30 seconds to 60 seconds to make sure that something...
Perfect.
Yeah.
Okay, I see some people who had to talk to their manager or their project lead. Are there any others?
I think it all boils down to managers and project leads.
Maybe. Okay.
Oh,
There are a few more coming. CEO, okay. So, but also a client. So I think upwards and downwards. Let me just give a little more time if anyone else still can think of any other role. But it could very well be that, yeah, for many it might actually be managers. That definitely seems to be the word popping up more. Okay. Well, as you went doing that, what did you have to communicate to these people? Could you also share a bit of those stories? Progress on the tasks, technical choices. results. That's something managers, of course, are very interested in. Also technical issues and achievements. Let me just wait a little bit more. But maybe I can, in the meantime, now set up to do a trick and switch screens. Because after hearing a bit about these experiences, well, you are lucky in terms of this audience that in many cases it's kept to a reasonably technical role. Stop sharing this screen and now go to my slides. Hang on for a little bit as I'm figuring this out.
We are waiting.
Now you see my slides, but I'm going to make them a little bigger. And now you fully see the slides.
And we don't see
and you almost see me. There
Awesome.
I am again. Right. So when I was invited to this session and asked to give a workshop or a talk to the PyLadies, I was wondering what I should talk about or what I should do. And ultimately, I settled down on this, introducing actually my experiences on communicating about models with stakeholders. And what I'm going to do is first of all to explain a bit how I became a communicator, then speak about communicating in 3 different ways. First of all, across disciplines, if you are in interdisciplinary work. Secondly, regarding accountability, if people want to understand why things go wrong or if you should be held accountable for that. But also communicating to lay people, after which I will conclude this talk. So as was introduced already, I have a bit of an unusual double background. On the one hand, I trained as a classical concert pianist in the conservatoire, and at the same time, I also was trained as a computer scientist. And on this connection between these two interests that I found just very interesting, I got this interest in collections, in filtering. Because as a musician, I really saw that the digital world had a lot of opportunities. I could find new repertoire, I could discover recordings of other people, but I really had to try very hard. Because if you would look at the music services that were there, Spotify already emerged back in the days I did my PhD. It was there, it functioned if you knew what you were exactly looking for, mostly in the pop world though, not really regarding, let's say, repertoire I wanted to play and that people didn't know yet. So from this type of interest, I entered this more cultural heritage oriented scene and the scene of search engines and recommender systems. Now there is one big party out there regarding search engines, that's Google. And I had been lucky that for my PhD, I was partially sponsored through them, which also landed me several internships in Silicon Valley, where I also worked as a software engineering intern on what then was Google Play Music, or even the onset of that service. Now it's merged into YouTube. I did return to the university after that because I wanted to be an academic. But as I did that initially, I did a lot of projects in music information retrieval in the field of making music more accessible. And that turned out a very interesting entrance because it was something, if you say you work on music, almost everyone can say something back to you, much more than if you say you study computer science. So often in my work, I really was one of the first people to be put out and put on stages if people wanted to hear something nice about technology that they could grasp. So I really was the one in speaking about what we did for digital music, but also, analysis questions, data science questions, even more academic questions. And of course, a piano does look nice in a picture, maybe a bit nicer than a laptop only. So that happens a lot from my PhD times already. But as a consequence, I did speak a lot about this work with people not necessarily in my technical field, where I was training at that moment a lot in signal processing, but also a lot of applied data science questions, and of course, as said, these information filtering questions. And as we went, that actually became much more pronounced. So especially because I think societal questions arose from the technologies I was working on. If you think of search and recommendation and filtering down the interest of people to certain recommendations, you are, of course, narrowing down their perspectives. At least you go from a lot of choice to little choice. And that could work. I mean, people cannot typically look at all the items in your collection. You just can't do that for Spotify, Netflix, and the likes. At the same time, of course, the items you only see, are those sufficient? Are they steering you? Is that okay? And then I also was asked a lot to speak about that in public. So I've been doing some of these public items, speaking about filter bubbles, about algorithmic selection, about retrievability and irretrievability and issues with that. But also quite recently, I actually ended up on the front page of Trouw, a rather big national newspaper, commenting also about the benefits scandal that happened in the Netherlands, which again, down the road, was a question in which algorithmic selection and filtering contributed to a big societal issue. And especially with this latter item, which happened a few weeks ago, I really started wondering a lot about my role as a technical person trying to explain this. And I really saw how journalists were struggling with asking me questions that I could actually answer. Generally, that had been the situation. Even before, when the University of the Netherlands, that's the thing on the left side, asked me to make an item about filter bubbles, I got questions that were in the ballpark of, we want to know how the algorithm of YouTube exactly works. And there is no such thing from a computer science perspective as the algorithm of YouTube. There is a lot of personalization, special stuff going on there. There might be A/B testing going on. You can't really say it's this particular one procedure, and you can certainly not explain it in 5 minutes. So this has been a big challenge to me, and that's why I feel it's good to talk about those experiences to you, which does mean that this talk is not necessarily a Pythonic talk. So I'm sorry to not code with you this time, or not speak about very language-specific issues. Still, I do think it might be hopefully insightful to several of you. So what I've been encountering moving into this space is a lot of Babylonic confusion. As I already mentioned, there are discussions about the algorithm, the robot, the system, where the designation of what it exactly is may be quite tricky to truly delineate. And sometimes also the data science work we do is a part of that whole thing. It's not the whole picture. We might, as a consequence, not be able to comment on the whole picture, but at the same time, it also doesn't mean we should fully disengage. So first of all, I started to learn to speak about work to other people when landing projects with people in other disciplines. I started with that in music, when I had to work with music ensembles, with musicologists. That was for me as a musician, of course, reasonably natural to do. But soon thereafter, I also started working with psychologists who were worried about the influence of, well, AI on job selection and hiring. And we did see already then in popular press, there were lots of promises and lots of concerns. On the one hand, these superhuman performance types of promises, computer-based personality judgments being more accurate than those of humans, maybe suggesting that we might want to do that. At the same time, this fear of the robots taking our jobs, or the robot being the thing selecting, or the algorithm being the thing selecting, where if algorithms were used, there was also some bad press about bias in there. So, of course, if we look at data that already is there, if we, for example, consider leadership positions and women, they might historically have much less been there. So if you look at the data as it stands today, you might predict for exactly that, and that might be not what you still want to uphold these days. So my colleagues who were organizational psychologists, who knew a lot about selection procedures in terms of how to interview, how to assess what characteristics are good for job candidates to have, they asked me to comment, but also collaborate with them on how algorithmic procedures could fairly be used in this whole image. But as we did that, really, I also learned a lot about things I found really trivial, and I found my colleagues didn't find trivial at all. One thing that struck me, and that really changed my view on this whole story, is that we both depart from a similar type of setup. We start with some data. It needs to be pre-processed. There is some training, some statistical model being fitted, and it leads to some optimized model, which might be used in some application. But as machine learning experts and as data scientists, we really focus on that center part. The data somehow got acquired already, we process it further. We might label it, but typically the labels also already are there. And you try to find the best model within that scope, within that realm. My colleagues, though, looked at the same pipeline, but really from another perspective, from the domain experts' focus, that they wanted to know whether there was a predictor in their data that they could tie to the application in a valid way. Actually, if you just look on that middle part, you can't tell if the data was valid or accurate or representative of the phenomenon you want to model. So you look at the same pipeline, but you're actually focusing on different aspects of this. And this gets even more interesting if you work with multimedia data, which is what I've been doing. So I've been working with music, I've been working with video, with images. And when I spoke to my colleagues in hiring, they had a lot of interest in video resumes, as one example. So people who self-presented themselves in a video and to see whether that could be a better way to represent one's interests and personality than a CV. But if we spoke about how to translate that to a more automated setting, there were a few issues popping up that, again, for me as a multimedia researcher, I've been navigating all my life. But for them, as psychologists who handled video as data, we both spoke about data. We thought we spoke about the same thing, but really we weren't. And regarding that, one big issue that we encountered is what's called the semantic gap. And that's been a term that's been going around for over 20 years in the multimedia world. That to humans, sometimes multimedia depictions have similarities that are very obvious, that to a computer are not. For example, if you look at all these different pictures, most of them are pictures of me, apart from one of them. But if you would just have these pictures and do straight on similarity based on colors, the closest image to the one on the left of me is actually the picture of my duo partner, because it was taken on the same stage under the same light conditions. So in terms of color balance, that will be much closer than all these other pictures of me. Furthermore, um, pictures typically, and videos too, in the raw representation are pixels with colors that might then move over time. And at that level, there is a huge difference that can be caused again by, for example, lighting conditions and framings. These are three pictures taken by me in the same environment. And you see that, well, it's three times me. I wear the same clothes, at least you see that in the pictures in the light. But these would, for a computer, be really very different representations. And that was really something that my colleagues didn't know up front. So they thought, like, that's all the same, right? And not trivially so. You really have to process if you want for these things to be close. Standardization was another phenomenon that happens naturally with us, because if we feed our data to a model, to a neural network, to anything in the middle, it needs to be able to be batch processed. But again, it is something that other people who've been curating data might not have been as consciously aware of. So one thing I really also had to explain was that a concept we may have could get a lot of exemplars in the data space that we acquire, that we label. But after that, they might have all different formats, different framings, and you do need to batch them more together in a standardized way to offer something, a framework that can do data-driven analyses that it can process. So the choices you make there, again, will affect what representations you get, and thus also what further conclusions you may draw. If I have to go from two different pictures in different formats, in different landscape and portrait sizes, to only square images of certain by certain pixel, there are different processes you can do. You can crop, you can scale. If you crop, you get a different result than when you scale. The advantage of scaling probably is you only have to do it once on your whole image. With cropping, you may need to take multiple crops, but with scaling, of course, dimensionalities get reshaped and reformed, and you get a warped image. So again, if you after that would have to compare these different representations to one another, it would matter. And this is again something that's computer-wise is logical, but human-wise might not be as such. Another thing that really struck me was that when my colleagues then started acquiring a video data set, I got something like this. I got a lot of videos, but there wasn't a very standardized protocol, at least not from, again, a technical perspective. So many people got instructions to make a video of themselves, but they ended up in different sizes, in different formats, in different lengths. And then again, if you have to process that in a data pipeline, well, you have to make some choice on how you're going to handle these differences and how you can, again, standardize and batch process. And that was something we couldn't really converge on how to do that in a way that we felt made things comparable. So these really were challenges that we hardly speak about, but that are very real. As said, the domain expert's focus is on those outer parts, but may even consider even further outer parts, that projection of your problem into data. Actually, if I looked at hiring, a lot of questions really were about, is this data fairly assessing people? Should we treat it differently? Do we need other types of data? Not about this data is there, we're going to make the best model out of it that we can. So even if that focus shifts, you may want to also shift the focus of the assessment. And to be real, actually, I have to squeeze that picture a little more because this is the true type of workflow we really are handling very often. Some problem gets projected into data, gets pre-processed, gets trained. There is some kind of optimized model coming out of it. But we deploy it then, of course, in another setting, potentially, a setting that may have distribution shifts, a setting that may have streaming data that changes over time. So it's not as if that optimized model always will be optimal. It's also not so that if that model operates in a bigger environment, that it's really that model that may truly be the trigger to a particular decision. There may be a lot of surrounding components out there too. So some questions as a researcher that I've also started pursuing more after running into these types of issues are questions like what you see above. What is working as intended in data-driven systems? And what even is the code that we are testing for? So I have now, for a few years already, started building a line on testing for machine learning with my colleague Annibale Panikella. And together we look at this, like what would be proper tests for machine learning systems? You might think of that at different levels, like you would do with software, maybe more at the unit level, maybe more at an integration level, maybe also in this case from a data and requirements perspective. So we do see some movements towards broadening that scope. And the more I work on this, the less convinced I am that a single metric will get us there. That really you have to look at this from a lot of different angles. And that is, of course, even more triggered these days. Now, there are more and more concerns about things not going so well, and systems actually making mistakes, outcomes actually being bad. So I'm going to, again, give a few seconds to you, considering the stream and the delay, to look at this cartoon, which I think is a very nice cartoon speaking about responsibility or accountability in AI.
And probably we need even more than 1 minute because now we experience it like 2 minutes delay between the stream and the setting. So let's just give more time.
Then I will just wait a bit longer. Maybe you can help me looking a bit at time then.
Yeah.
But I will wait for a bit indeed then to.
Okay, we'll handle it.
Yeah. That is the beauty of multimedia delivery. Yeah? At the same time, Eliana, if the stream is delayed, but I don't require input, at some point people arrive here, right? So
yeah,
if I don't really even need a discussion, I can proceed already, I think.
Yeah.
As they will see me waiting. So
yes, right. Correct.
Great. No problem, because in terms of interaction, of course, there are different delays. We're figuring this out.
Of course.
I think by now
time is a complicated thing.
Yeah, I know. So I think I don't have to freeze too long, because if people see this now, they will have read the whole story, I think. Yeah, so there are now big discussions going on regulating AI, regulating high-risk systems that operate on data. Even there, the exact definition of what is AI or what is the data-driven system or what's a high-risk system, lots of debates, lots of different interpretations there. But what I typically see in terms of questions being posed there are things along these lines. I want to know exactly what the algorithm is doing. And then again, the question really is like, the algorithm, what is that? The code, what is that? What should I exactly explain to you? And sometimes this can be misused. What I want to highlight to you is a letter that was sent by the Employee Insurance Agency in the Netherlands this last summer. If you read Dutch, I have a URL out there, and I do encourage, after this talk, I'll show you the slides, to look into that. So this was a request that was put to this instance. In the Netherlands, you have the right to request information from government institutions. And in response to such a request, which was about their risk assessment models, they wrote this letter and they reacted in a particular way. So the questions that were asked to them were about automated risk assessment. So basically trying to score people there on whether there might be potential issues or signals of fraud. And one question posed was for the people who requested this to get the source code of used software and algorithms. And the reaction of UWV, of this instance, was that they said, well, in terms of software and algorithms, we use Python 3.7.5. And we also use SQL Server 2016, which is licensed by Microsoft, so we cannot share source code. Python, well, that is open source, but because it's open source, we won't share it either because you can find it. And our model, well, our model can be found at, and then we got the scikit-learn link to the gradient boosting algorithm. So this is, to me, a bit, well, technically correct if people ask for source code of used software and algorithms, and at the same time, definitely, of course, not what people really are looking for if they ask for this in the context of being suspicious about a risk scoring algorithm. Really what people are looking for is for this trained model. The way things got optimized, that's much less of the concern. And regarding that, there actually was a response where they also said, well, we actually did document our algorithms. We did have scripts. We made a data protection impact assessment, but we're not going to share those because of the strategic importance to our servicing. And of course, if you speak about these risk assessments, especially in the context of fraud, of course, there is an argument to make that if you know how you might think people are fraudulent and people are really fraudulent, if they know that, they will take another tactic. So it is true that there might be a more business related risk out there. At the same time, this was a very easy way out, and it's, I think, not a good way out. But still, I've even seen this with more better meaning instances. This Saturday, I will actually be on national radio commenting about another risk scoring algorithm of the municipality of Rotterdam. They have been cooperative in these types of requests by the journalists who made this item, and did also release the training scripts. But indeed, the training scripts don't yet get you there in terms of assessing and auditing whether things are fair, whether things are the way they should be, whether there might be any judgmental biases in there that you don't want. You need a much bigger picture beyond the optimization towards a particular model. Also, in terms of the audit, you want to then audit the trained model and not necessarily the code that led to it. But indeed, of course, if we think of our data science work, the code we even write are, of course, many times the scripts that attach these things to each other, that ingest the data, that process it, that then learn something out of it. But the result is not something we code out. So I can even imagine that I might myself not yet even be so settled on what I should exactly share here. Some common problematic questions I encountered in this context, again, have to do with this bigger picture, and then again, pointing and scoping. When I worked on this radio program for Saturday, I got this message that this, of course, is a very complicated matter. Often what you also see is that people who have domain specialism typically tend to really not consider themselves very technical. So if you try talking about more mathematical or technical approaches, they will just filter themselves out beforehand. But then in terms of understanding better what happens, I got a question first if I could walk the journalists through the code live while being recorded on the comments. And I told them, like, well, if I look at this code, I can definitely walk you through it. But I don't really think it's the level you want to have in terms of the discussion, especially if your audience also is not necessarily a technical audience. I mean, I see the scripts to pre-process, I see the scripts to ingest the data, I see the ways in which the data is then further processed and used, and how different training models are used and assessed. That's really that small middle part, again, where much of data science and machine learning happens. But it will not be the details that will allow for me to explain to you whether this is an okay way to put it or not. You really need that bigger picture once again. Another question I then got was, should a particular sensitive attribute have been included? Should we have known whether someone is male or female, or what their age is? Those types of questions. Of course, there is a more philosophical argument to be made about this. Of course, there are ways to see if you might skew towards some of these. But an interesting thing, again, looking more critically at the code, was that this particular algorithm had a feature selection step. So even if an attribute was in the data set, it was not necessarily used in a final converged model. And again, that's an extra layer of complexity that for many outsiders is way, way too complicated. But it again makes it a bit ambiguous on whether attributes are included or not in case they do or don't contribute to a particular outcome. And very often the question much more is whether that outcome should have been the outcome that was labeled as such, whether the civil servant who started this data wasn't actually a biased person who put it in. So again, I found myself struggling on this boundary between the insight training model assessment, the ways to see if beyond accuracy, even other metrics maybe showed any disbalances. But the surrounding problem, the surrounding decisions, that was something I, of course, didn't yet have access to, which also wasn't asked yet. So this is once again in our calls for more accountability, something we really should take into account, I feel, much more than we do now. Because currently there's a lot of discussion about self-auditing and having checklists that you look at. I think it's good. I think we need to very consciously reflect on this, but we need to keep the discussion going again with the outer parts, because as one other interesting dilemma in the story, the risk scoring algorithm I was looking for this Saturday was about trying to assess whether an application for benefit of the city was actually correct. And this question of correctness could also be, you can make a mistake on a form, right? And then it's also not correct, and you will have to correct it, and you would have to be checked. So in itself, it's not necessarily a bad thing. And then if the question is if, for example, people who don't have Dutch as their first language, if we should have known that when starting to train, well, if your form is incomprehensible, you may want to maybe know if there might be any comprehension issues there, and you may need to know that. Of course, if the consequence is that you will check people by making their life miserable and telling them they are potential frauds, that's a whole different story. So it's much more, again, not just the insight, but also what you do with the insight and why you get the insight. And again, those types of bigger picture questions, they typically are put with the organization as a bigger whole, or maybe with the managers. And I'm not always sure whether there is enough comprehension that those aren't actually the same problems. So what I've done, seeing this, is that I really started communicating more to lay people, to people who didn't get any training in programming or machine learning or data science, but who do want to form opinions about these. So what I wanted to do is just to share a bit more how I've been doing that, and also how I started realizing what the differences really are in approaches and what the points are to highlight. So first of all, I think something that's very important to notice to other people is that you are trying to learn patterns from data. And typically I then start with a relatively harmless example. This one was made by my PhD candidate, Patrick Altmaier, where to, for example, discriminate dogs from cats. Dogs are having a shorter tail than cats, but they might be a bit higher in terms of their shoulder height. So you could imagine there might be clusters like that. Based on the tail length and based on the height, you could indeed distinguish dogs from cats. And you would train your models based on the data that you know. But the interesting things, of course, happen if you get a null point that you didn't measure. And the question then would be, is this a dog or a cat? Well, and based on what you already had in terms of your observations, in this case, you would maybe deem it more likely that this could be a cat and rather not a dog. In our space, typically, we don't have those contexts anymore. We often have worlds like this, and this is just simple, this scikit-learn example of two different classes that you need to separate. And if I first show an example like this, I would normally also talk with my audiences about, well, if you look at this, can you separate red from blue? Well, you can kind of draw a line. So maybe even more linear types of models would work here. That becomes harder with distributions like these. In such cases, you need something fancier than drawing a straight line. And saying that, I can then move on and show them things like this. This is again just the default scikit-learn examples in their tutorial. But I just show like this often is the technical work we do, trying to find the right model that fits the data the best, that separates them the best, which might operate on different types of criteria, on different types of optimizations. A lot of our work really goes here. And then, of course, depending on your choice of model, there might be different performance successes coming out of that, and you might select a model based on that. Yet, once again, there will be some consequences if you have unseen data, which might be a bit on the boundary. What will happen to that? Will this be blue or will this be red? Well, for different potential models you might choose, that may actually be a different decision. So this is again something that I felt was quite important to highlight. It's not just about fitting the best on the data you have, but mostly about the choice you make afterwards. And taking that a little further, data is of course being used for decision making. So if you have, again, two different classes, say in this case, crosses and stars, there are of course many ways to separate these, but what you often see is that there are a lot of further data points that will happen beyond training and testing because you didn't have it yet, and then you have to make decisions based on that. And for these squares that we hadn't seen before, maybe you can only pick 5 of them to make a decision on or have a consequence on, because we cannot serve everything. Like in Netflix, we cannot watch all the movies before knowing which ones are nice. So you need to select and you need to filter there. And that's where the interesting things happen again. So what I will now do is go into yet another part of interactivity, which will mean that I will freeze in a bit. But what I will do is to now forward you to Qualtrics, to an online surveying platform at TU Delft, where I am actually first asking you for permission if I may even use your anonymous responses in my further research, because I've been doing this exercise with a few potential policy making people or people interested in this matter. But I'd also be quite curious to see what the PyLadies are doing, if you would agree. So first you have that consent, and then you will see the data I just showed you, but with different interpretations. There will actually now be a meaning associated to what a star or a cross means. You will see 2 different dimensions where the dimensions will now have also interpretations where further away from the 0 point, some particular attribute gets bigger. And based on the use case you see explained there, based on the question of selecting 5, you can then pick 5 points on your phone or on your browser. And I'd be quite curious to see what you would select in those different use cases I'm showing you. So I will now leave this up for a while, and at the same time then have you, as soon as the stream catches up, going through Qualtrics and picking your 5 points on these different use cases. So I'll give this a bit of time. On the image, I will now go a little bit silent for a while, but let's see, and I should be able to check the responses coming in.
I have a question. It's a bit,
Yes.
I don't want to be annoying, but why do you need our consent if it's anonymous? I guess.
Well,
I mean, it's just I'm being annoying, but
It is a good question. I must say that I have gotten the instruction to actually have ethics approval on any user study I would do now. And even there, I'm now in kind of tricky realm because I didn't ask for ethics approval because I thought that's really too much. But because of that, I still want to, just in case I get questions on this, show that there is consent. And in that sense, it's a small thing.
Makes sense. Okay, so it's more not the GDPR so much, but just the ethics.
It's more on the ethics
like
side.
a good practice.
Yeah. So it's really just following the principles that now are being put. And I must indeed confess that regarding this, I think academic institutions got really strict, way more than what I sometimes see happening in many other contexts. But at the same time, I guess it's a better thing to be careful still and to indeed inform. Yeah.
Agree. I'll try to complete the exercise.
Thank you. So I'll be looking a bit on my other screen now. You'll see me looking on the other side, but then I can hopefully see some results popping in too.
I would say it was really tricky questions.
Which is good because it makes you think.
Yeah, I'm really curious to see the end results actually.
All right, some of you are still working, some of you finished, so I'll just wait to see the responses in progress also finishing up.
While we're waiting, Cynthia, I have actually like a question. So for those who will be rewatching the stream, or for those who will join the stream later, will be this latest survey available?
Yes, I can keep this survey open. I'm not too sure about the Mentimeter because that tends
No,
to...
Mentimeter not, but we are more interested in this part, right?
I can keep this open. So what we will do, considering that maybe more people might want to try this, is that after I see people finishing this, I will actually just go on with my presentation for now. So I can then talk the ones who are here now through what I've seen so far. In that case, people who might do the exercise will then not after that actually see what the rest did, but
Cool.
still can finish it. And then let's say at the end of the presentation, I will then open that and see what happened there.
Awesome. Right? Good idea.
You can also in the code repository later maybe also print out some things if it's about
definitely,
the
definitely. Yes,
Yeah.
yes. So what I could do for sure, at least for Mentimeter, I will put what already was there in the slides. And for this, I will indeed then also keep it for now, but I will check in then a few weeks maybe, and then maybe have a screenshot of what I'm seeing. Yeah. So for those watching later, feel free to still participate. We'll figure something out.
Nice.
Thanks a lot. Cool.
So I see there still are some responses in progress, but considering there is, of course, some delay, maybe I can just continue presenting at this point because I am actually already reaching the conclusion. So while those of you still working on this are wrapping this up, anyway, you'll hear this a little later than I'm now here. So let me continue. Yeah, as said, I'm actually already reaching my conclusion now, but I do want to point out that I feel it's important to grow literacy, especially at those interfaces between the data-driven pipelines, but also their surrounding contexts. And that is not only about teaching everyone machine learning and programming. Typically, it's been mentioned as the intervention to do. And I definitely think it's very good if people learn this more, if they get a better feel for what it is to code, what you need to think about when you code, what it is to model in a machine learning or data-driven setting. But only knowing that, I feel is not enough. I really think we need to think about these translations between problem, data, and then what happens to the data. So that's something I really myself have, of course, been pushing now lately more and more. But I do hope that some of you listening might agree and also take up this this further with your environments. I think we can do it. I do think it's non-trivial, but yeah, I hope this gave you some thoughts. And I just added some references to the slide deck for those who want to read a bit more on what I've been doing both with psychologists and with regard to software testing as a paradigm. But now I'd be happy to first take any questions and at the end take a first peek at what we did in the survey. So that's it.
Cool. Thanks a lot. I think before we wait in for some questions due to our delay, all right, I have a question to you, so I will use this time.
Do that, yeah.
So
do you prefer for me to actually take out this slide now so you see me a bit bigger? Is that
yeah,
better?
sure. Yeah,
Then I
get
will
back
just
to us.
stop.
Yeah.
And now I should pop up a bit more
Yep.
bigger then. There we are.
Awesome.
Yeah.
Cool. So I'm really wondering regarding this article about this benefit scandal. So what was for you the most, let's say, impressive things that you managed to dig up?
The most impressive things. Let's say the most scary thing I found was that I had hoped I could be really angry at the tax office and say, look at these idiots just having done things wrongly. And then I read the documents and I thought, like, actually, a lot went wrong, but a lot went wrong at different places, and I could just see it happening again. And that probably to me was the biggest shock. And again, modeling and the requirements and the thinking of what kind of features one wanted to use, that all happens with experts, actually, not just with data scientists, with experts, but in focus sessions that were held more than 10 years ago. And that was a time when GDPR wasn't yet there, when we didn't think so much about our data, when we were so optimistic still about big data and just measuring whatever was there and quantifying whatever was there. So that consciousness we have now, that wasn't there back then. And it, of course, seeps into the data that was acquired and ingested then. Following on to that, what you saw was this huge compartmentalization of roles. So the data got to a data science team that actually used enterprise software for modeling, where they, as a consequence, hadn't even in that sense been coding themselves. They used a package that had particular models that in its documentation even, for example, claims to handle correlation, and I doubt it looking at how the model is at least mathematically specified, but it says we can handle it. So even in terms of doing that, the responsibility again outsources to that software package that does this, which is a commercial package that I cannot get access to. Even in terms of the labeling, they used a credit risk scoring model, and this was again a risk scoring model. They wanted to see what applications were somehow fishy. But then again, if you speak about credit risk, it's about whether you want to grant a big loan to someone. And if that is so, I can imagine that, let's say, if someone is a poor student, you might not want to give that person a lot of money. So there you could see that if there are multiple indicators stacking together, even if they are correlated, maybe in a loan situation, it could be justified to consider them together as indeed extra risk. But that's risk of not being able to pay back the loan. Now, if it's about applying for benefit, it actually, as a consequence, might much more measure that you need the money much worse, right? So the risk that they now kind of try to transfer, they interpreted that as risk of someone being a fraud, where at the same time use of indicators, they pretended as if they were predicting for risk according to credit. And people with a very high credit risk probably were the people really, really needing those benefits and actually being the people who needed them the most and who were the worst hit when things hit there. So that again led to, I think, this extra feedback issue of targeting particular people, the single mothers with a lot of children who didn't speak Dutch very well. And then afterwards, they also said this was not an algorithmic decision system because there was a ranking coming out of this with a score, but the civil servant had to decide what to do next. And the civil servant got a score, and they didn't want for the civil servant to be biased, so they didn't actually give an explanation to why that score came into being. Just, these are people who score badly, maybe check or decide what you want to do with that. And that person was not a highly educated person, it was a paper pushing servant. So this person was just like, well, the computer says that this is a problem, so I guess it's fine, right? So I just saw that happening in the wiring, at least from the documentation you read, that you think like this is a disaster happening. You just feel it. And at the same time, you just see it happening. And with all the checks and balances we now put into place about document better, indicator risks, they have a human in the loop. Well, they kind of did that. They had a human in the loop, a lot of humans. And that exactly was where the problem started. So it really just made me very worried about this not being enough. And that's, I think, the most interesting takeaway from this.
Well, especially in politics, not all humans in the loop are the same. If the right human in the loop had signed every one of those papers, then maybe that human in the loop. But yeah.
Yeah, no, exactly. And that's also where in bigger organizational wirings, like a huge tax office of a government, it's very easy that things seep away, and even the incentive models behind it. There were like targets they had to catch to earn back the funding that was put into them as a tax office. So they had like so many million euros to in terms of illegitimate requests to get back, because they had to earn that back. So even the targets they operated on as employees kind of was an extra reason to be super strict and really bad. And politically, we were in a climate where people were, yeah, even targeting, let's say, foreign people who profited of the state even more. So there was this sentiment, and that's again where currently, uh, let's say, the parliament even is a bit careful in because they had been really feeding into that climate too, and that's now used as the argument, like you also did it. So even here, it's super easy to now just escape from the responsibility because you have a lot of fail-safes for that, in how things ended up.
But this indeed reminds of this scary cartoon. When it's not me, it's just like I just put
It's the
all this
algorithm.
data about you into the algorithm. Just algorithm did it, it's not my responsibility. The responsibility of algorithm.
Yeah.
Yeah, and I think probably that the biggest question, especially in the huge companies, huge enterprises, is that try to use AI and do magic with it, is mostly in the sense of who is going to be accountable for wrongdoings of the model of an algorithm, and on top of it, who will be accountable if the algorithm will give one word but the person will interpret it completely different. So I think probably that's the most interesting part.
Yes.
Like while we're like waiting for anyone, if anyone who wants to ask a question, do it in the chat. We're gonna translate it to Cynthia, and I think probably also I'm dominating today.
Well, I have a question, but it's still related to the same, because
Go
you
on.
said Cynthia, I think you said I see it happening again, but I would like to ask, how would you avoid it?
So well, by hopefully having the awareness, like things I'm trying here,
Right.
getting more into more minds, because what I see also from more the let's say managerial policy making side is that people also have a lot of misconceptions about algorithms, right? So first of all, what the algorithm is, it sounds like a very easily designated thing, but it's really the system in its social technical context, where for example with the text story, it's also that whole process of who at what point pushes what paper with what information, where in terms of power, that poor servant that got the scores was in no way capable to step up and say, this looks fishy, is this okay? So there organizationally, I think there needs to be way more rethinking of what is this about. It's not just about data and predicting more accurate. We as data people should be a bit more careful, I think, in our claims, because we've, of course, and especially in the academic world, you're very much incentivized to come with like the smarter, newer, better, more complicated algorithm that outperforms the humans. But that's again in your modeling space, given your data, hoping your data is clean. So a big issue is that you see this translation happening a lot in all the very optimistic talk about AI and data. This better than humans thing comes a lot. And whenever I spoke with people who talk to me about their data problems, they always tell me like the algorithm is more objective and it's better than humans, right? So I don't know what to do with this, but you surely can figure this out. And that's where I'm like, no. You have to tell me what I should tell the algorithm to train on. So no, it doesn't work like this. But there we really need to learn to push back. So one thing really in TU Delft now we're trying to push is this idea of responsible engineering, responsible AI. But I really hope to teach my students to dare to step up and think about the problem in a broader context. So you get your data, you get your numbers, it looks really good. You might get your 90% accuracy, if not higher, but step back and what does this mean, and what happens if this actually isn't what it's supposed to mean. That's way more vague, but I think we need to train that.
Yeah, I think personally, but I think not all of these problems are new. I studied business administration like 10 years ago or more. And they gave us ethics, and they said, there's this car maker company, and they discovered that if they need to do a recall, if they don't do a recall, X number of people will have an accident that will lead to suing. But if they do the recall, then that will cost more than getting sued. what should the company do? So go ahead with the recall or accept the suing from the accidents. So some of these problems are not totally new. I think what is new is the tools that we have now and not falling blindly to the hype of the power of AI.
I totally agree. And another issue is, of course, what I've also really experienced is this whole story of data and software. It's way less tangible than many other issues we've seen before. So I've recently learned a bit from colleagues in Delft here about aircraft safety, where in terms of if a crash happens, there are big protocols also about figuring out what happened with the black box, but also the accountability story is actually separated from the investigation, where currently the AI regulation stories really are about who is at fault, really are about blaming. And what worries me a little bit with that is that as soon as, of course, you will probably be blamed, it's very nice to not be blamed, so you will duck. But it also means that you get less transparent. So my fear really is also with these auditing stories and transparency issues that we really are walking a very thin line there. And if we want for parties to be more transparent and open, we should also have a very open discussion with them. Similarly, when I, for this Saturday, was speaking about this risk algorithm at the municipality, I like that they put a code there. I think they really did a nice job on that. There were some things that were not so great, but they opened their report, they published it, they had a huge discussion also on potentially being biased, and they went for that. Which I think is a good thing. So I would definitely not be in the position to say like, bad people, look what stupid things you did. They didn't. They tried, and no one knows yet what to do. So we need to also create that environment of trust, I think, to get us to speak a bit more openly about this, rather than directly saying like, you're really wrong and you shouldn't do that.
Indeed. I think that the human side, right? Now it's AI. In 10, 15 years, 20 years, who knows what they will be.
Something else, maybe.
And we still need to be responsible and, right, not forget the human side.
Absolutely true.
I'm really curious to hear, you already today, let's say, mention it briefly, but I want to get, let's say, more formed advice from your side. So indeed, due to huge difference in the way how we explain things to each other, especially with the technical people, we are more going or inclined into the talking regarding, for example, metrics, model performance, and everything. But then when the model is deployed, depends on which way the model is deployed, how this model will be consumed, by whom. There are completely, let's say, different set of discussion that should be. So to summarize, what will be your advice for, let's say, junior data scientist to communicate it properly to, let's say, to senior data scientist, and also to managers like product manager, product owner?
Yes. First of all, I do think even those different communication lines require different strategies. So one thing I did notice was that when I was also trained in this matter, that was about the time of the big data hype. So that time, whatever you could measure, you just added it. And again, that's how we've been raised. And many of us are thinking like that. Many of us who were raised at that time, we were just taught or thinking that ethics was a soft, fluffy thing that was not technical, so not cool. Only very recently, now these huge social scandals are coming up. People get much more conscious on this. We see it also in our own students. A few years ago, when you speak about these types of issues, it's too soft. They don't want to engage. Now they start to think like, oh wait, maybe we built these systems. Maybe we should do something about this. So in terms of interacting with senior data scientists, I can imagine that many of them still are of that old philosophy that if the data is there, it's just not my problem. I assume the data is good. It was someone else's duty. We go on. So that is something to be aware of, that this might not be the case. And the reason why I put the exercise up is that it's exactly the same distribution. It's exactly the same data points, but as you see in 3 different cases, you may actually make different decisions. You actually did. So I might indeed maybe not even say too much about it, but later on in a few days, just post some pictures in some slides extra to the repo. In the examples I gave, without giving too much away for those who are still watching, in some cases, the 2 dimensions may have more meaning than in others, but it still could lead to the same data set. And where we optimize, we have the data set, we just separate, and you see the correlations in there. but that's not always what you really should do at the decision-making table. And there, that will then be more of a PM discussion, that will be more of a managerial discussion, but make sure that these people don't, because you claim the performance is fine, take it, and then it's not their problem anymore. That's also where I sometimes see a bit of worry that because a metric is so nice and it's a numerical thing, you can hide behind it, even though it might completely incentivize the wrong thing. So regarding that, I think with managers, with PMs, first of all, also for them, the awareness that what they ask of you is not a full translation of the problem that they are facing. They work, I think, in a bigger context. You work on a part of this, but of course, what you do in that part actually has huge influence on the rest. Try to get on the tables, try to get these discussions in, point to all the big scandals we now have, because people know that, and no one wants to create a benefit scandal with all the publicity around it. So make sure that we do now have like reasons to shock people with this story, and at the same time, I think very practical ways forward. Regarding this also, it might help if you speak about bias to start with these innocent examples, because if you start with straight on discrimination or any other big topic, of course there's a lot of ideology behind what counts as discrimination or not, so you risk to directly enter a polarized discussion then. And I've been very lucky coming from music that I was saying like, well, there's music you like, there's music you don't like. If you only get the music served that everyone listens to at this moment, are you happy? Some people are, some people are not. But if we conflict on that opinion, it's okay. No one gets upset at you. And then it's like, okay, but this is this filtering and selection procedure, and now this actually also holds for these other cases. So even using that the same technical framing can actually have a lot of different applications. Maybe start there with the dogs, the cats, and the music, and then go into the bigger issues. Because then people actually already bought into that this was an issue, and then you're like, yeah, so it's actually the same, right? So that's a trick that I've been using that works very well so far.
Start with cats and dogs, or
Start with cats and dogs.
rock and rap before you go into race.
Something like that. Yeah, absolutely.
Okay, cool. Thanks a lot. I also wondering, let's say, what's your intake on the also like this? I don't know why I'm still keep asking about the scandals, but I'm just wondering what your intake on this like Zillow scandal that was also pretty like owing newspaper space internationally.
Yeah, remind me again what the issue was there. It was a discrimination bias case again?
It was let's say the algorithm that was predicting the price of the house, and then it was like
right, yeah.
The platform that was allowed you to put your house there. It was then algorithm will predict the price. This house will be bought by the company, by the Zillow company. It will be then renovated, and then it will be sold with a huge overpriced, let's say.
Well, again, I think here the question is it then actually the market mechanism that gets incentivized in a certain way, or the algorithm, right? So again, probably the discussion now is a lot on the algorithm, but the huge issue really is that with this insight, people go practice like this and push some people out, which we've seen in a lot of these platform-based services. Of course, the Ubers, etc., and the treatment of workers in those gig spaces has been a bit of a similar type of discussion where you optimize their schedulings, package deliveries to be very efficient, and then you really make their lives really bad as workers. So yeah, well, I'm on the one hand happy that the discussion now is had, because even regarding this, I think practices like these existed before and no one ever spoke about it because it just was the way the world was. Where now, maybe thanks to people being scared of the algorithm, suddenly they start talking about this or being worried. Where admittedly, with the algorithm, you get to skill it much more subtly, and suddenly it's everywhere. So that is a true thing, that of course, by doing things algorithmically, we can skill in a way that wasn't done yet. So the skill and the effect of the skill is definitely amplifying this. So, well, again, I can imagine there's a lot of ideology behind this on whether this is considered an acceptable practice or not. I think we would definitely not like this at all. I could imagine some spaces where this is perfectly acceptable. This is also why, for example, in the US, there are so many discussions about fairness from a social justice perspective, because there it's been much more ingrained in society that this is okay. And now many people are like, no, this is not okay. But it also shows how normative this is. So once again, this needs to just be out in the debate, and people need to take stances regarding this.
Yeah, thanks. Yeah, I do agree. But also, it was like really, really funny to see that there are a lot right now a push for AutoML, for example, and it's pushed by like, oh, in just 2 clicks you can replace the whole army of data scientists, you know, and you just get your model and you can deploy it immediately in 1 click, and it's awesome. But then you start thinking, first of all, how much compute are wasted, and secondly, like, data scientist is here not just to build algorithm, right? So it's not about this.
Well, and again, I can imagine that once again, from a pragmatic perspective, in a lot of the spaces we've seen being taught, I can see a message like this happening. On the banana set, it's perfectly harmless and you can do it, right? It's just that this awareness of that the data points could mean something different. It's always been outsourced. It's always been outsourced to the domain, and many people who push these types of libraries might still consider it to be the thing of the data experts, the domain experts. They may need to talk to some data people, but that's the data cleaning anyway. That's not the data science. I mean, typically you see that designation too, which is also not very rightful. But very often we really kick on the predictions and not on everything, the messy stuff before. Where I think the really interesting things happen in the messy stuff. Because also what to include, what to exclude, how to clean, how to standardize, as said. There are huge implications of what you do there that you cannot always forecast upfront with a number attached. Because depending on what your outcome is, if you think object detection, if I mistake a dog for a cat in ImageNet, that could be like an actual mistake. If it's a self-driving car, as long as it's an object, probably it's fine. So even here, the other way around, the way you treat a mistake, how you count it, how you measure that, it does matter really on what you ultimately want to do with that.
Yeah, but also, you know, like the funny thing is, also there is like a tendency for industrializing machine learning now, making more operational. We all hear like the term like MLOps. And I do agree there is still a lot of really fuzzy and vague practices, but there is also one practice that just, how to get a timely feedback on the performance. I mean, not on the performance, on the predictions delivered by the model, and how to make sure that this feedback could be ingrained into the further, for example, retrainment, producing a new version of model, or like something like this. And from one side, it's nice because it makes, you can literally have a blueprint, and based on this blueprint, you can faster deploy more models. And at the same side, due to nature of deployment of different models, sometimes it's really, really hard to build the same feedback loop. As just you said, imagine if we get back to this benefit scandal. So literally what we were like having a loop that, let's say, supports this loop even more, because it was just sample of specific application that looks fishy, right? And then these applications were actually chosen as a benchmark, but we don't know in the whole pool of application. I don't know like the numbers of these applications. I just like random guess, like imagine, I don't know, like 1 million application. So we just take a small sample and said, this is wrong, this is right. But we never check the whole sample.
Yeah. Absolutely. I mean, and these are issues I think we will keep facing, because the skill at which we work, you can't look at all your different data points. You can't. So you have to indeed learn as you go. And I do like the movement now towards more ML ops types of focused setup. I do generally like to look a bit at the more software development oriented lifecycle treatments that you interact there with stakeholders from whom you should get requirements in a way that they also might not be able to explain so well. It's been ingrained in that culture more deeply. So I think, and we of course came much more out of maximizing accuracy. So doing more what you think is right. And maybe at some point you overfit. So I think that now seeing that more as a system where this is in context, definitely a lot of the propositions in there will start getting us more there, although still they wouldn't question the truth of the ground truth, if I may say it that way. And that's just much more of a philosophical question, but also really just an experimental validity question. Did you sample this properly? Did it actually reflect what you think it should reflect? And there is a lot of convenience happening in that space still that we, well, tend to not really think about if all the indicators look good. So it helped me also there really to work with the social scientists, because psychologists are super picky about this. They really want to measure very, very well because they have replication crises happening in their field. So this really makes me much more humble regarding that. Like, okay, what is this indicator? Is it actually a proper indicator? Can I get more evidence on that? Okay, technically that's not machine learning or data science, but still it's measurement. And if I don't get this right, the rest will just not make sense. So yeah, I think we can again learn a lot just to keep talking to others on how they see the problem and what they consider the data or the insight, and if you actually are matching that in your subspace there.
Maybe more work in interdisciplinary teams or multidisciplinary, so not an army of data scientists, but okay, some really good data scientists, which are heavy in the science, with like domain experts, some psychologists, something like that.
Yeah, I think so. But again, the tricky thing though, it's always also is a bit of an organizational risk, because as said, even between disciplines, you won't speak the same language. I mean, if I use the word data or model, even with my software testing colleague, code, right? We start disagreeing on what we exactly mean, even though we can
Well,
talk.
I don't know. It just depends who you talk to, because when you
That's
showed
true. Yeah.
what they revealed, like the version of Python, the version of SQL, come on. Okay, look, if
Yes.
we're really talking, a model is a series of operations on data. You have to
Yeah.
input, and it's not just magically goes through Python 375. Now, what
Yeah.
happened? Where did you add? Where did you divide? Which columns? When you take your time and okay,
That is true.
how
That is true.
what did
Yeah.
you start with the data set? Which features did you have? You included sex, okay, but what did you do with sex? Was there were you just giving them or a banana or an apple, or
Yeah.
yeah,
Yeah. No, absolutely.
some
Absolutely.
things
Yeah.
are just really going back to the basics and the roots of the science of it.
Yes.
Yeah.
No, that's definitely true. And here again, I think in that sense, in the training also of the managers, teaching them Python is one thing, but they do need to learn a bit more than that, I do think, and also maybe label the data themselves for a little bit and feel what happens there, ideally, and make a choice that they can be held accountable for later on. So that's of course a very ambitious thing. I'm not sure if that will work in practice, but I think we do need to think about that type of awareness.
Mhm.
And as said, what we saw, so with this particular request of the UWV and that Python story, all of us will frown when seeing this, right? We will just immediately think like, no way. But okay, again, technically they did come with software and algorithms. It was technically an answer to that question, and the people who got it back, I think it also was journalists. They were really puzzled. They were like, "That looks really complicated. Look, that's code. That's Python code. It's scikit-learn."
Yeah,
And
well,
then they
yeah.
asked, yeah,
If you give Python with the major minor version, oh my God, Python
yeah,
375, that must be
yeah,
so
exactly.
complicated.
So
Okay, that's just a version. That's,
yeah, exactly.
Python 263 probably did the same bias. So,
Yeah, but it's just funny to see how little then the regulators and the politicians get this, and also the journalists. So when this journalist who found that came to a friend of mine and me, like it feels strange, but I can't put my finger on what is the strange thing. And we were both like, no way. But yeah, what would you otherwise ask if they just immediately push back on the data, and they even might justify that partially? So really we had to do a lot of talking and coaching behind the screens, and if you also see the discussions on the benefit story still, when it happened and this story got in the newspaper, well, parliament was there that same day and asked questions like, now we want to know everything. And then everything, what is it? Just everything. Okay. And then the secretary of state said, okay, I will send you the model. And I was just listening to this conversation like, what are we going to get next, I still have to look into the 75 attachments they sent afterwards, but I'm really not sure what happened then. Yeah.
I do hope, that this conversation eventually will lead to a new type of profession, for example, like machine learning investigator, or I don't like data investigator, and probably, I don't know, like in 5 years, we will see that it will be taught in TU Delft.
It sounds like a cool brand, actually. I never thought about investigator there, but
Data lawyer. Data lawyer.
well, definitely. I mean, I've also been talking to colleagues in law, indeed, and also talking about this regulation story. Because if you look at the AI Act, I'm not a lawyer, I'm not a legal scholar, but currently, apparently, in the European AI Act, there are lots of discussions about the exact definition of AI. Where again, the more exact you technically get, the more you push out the bad Excel spreadsheets. Where many people say that's not data science, and indeed, it's not serious data science. But if, as a consequence, you get a rule in a system that says like if foreigner then fraud, it's like a heuristic based on a bad data example, which then is completely exempt of these types of regulations if you're not careful. So here I'm just a little worried about the more precise we get, the more we actually push the real problems out. And I still don't know how this pans out because some of these applications are considered high risk, so maybe still in scope, but it's funny to see that, and how many of these notions about AI never really defined very clearly because there is no clear definition.
Python 3.7.5 is
3.7.5.
AI. Anything outside of that?
Yeah.
And Microsoft SQL Server 2016.
Exactly. You
Yeah,
can use 2015 and be biased. That's okay. But 2016,
oh, it's really bad now. Yes, exactly.
well, it's serious. But yeah, it has to be talked about. So
Yeah, definitely. But I think I'm really, really wondering also, like, are there any right now I don't know, proper word for it, like movement within TU Delft that aim for like to raise the awareness about these situations, and it has some specific, I don't know, like form that people who are interested can follow or join or
Well, we're working on that. So I did get a grant recently for the coming 2 years. It's called an education fellowship, where I'm actually going to revise and get some guidelines on how to teach responsible AI practice, especially at our master's levels. Because what I found, as I also alluded to a little bit in my talk, is that I find it very important that students understand setting the problems. And I'm seeing a lot in our current education that also because there's little time, you tend to go to the default data sets. You tend to teach vision with ImageNet, right? That's the easier thing to do. So also recommender systems, there are lots of benchmark data sets already there, and that's typically where you go. You look at the Netflix data as it was the movie lens data or anything else. But the true problem is, like, if you want to make a recommender from scratch and you don't know what you need to filter and you need to show that and you need to go through a requirements process, maybe you get something really different than this particular data set. So that like sense of design thinking, that sense of critical thinking, but also academic thinking, because you might need a true experiment before you know what you actually want to measure. We try to now much more put that in our teaching. We're revising our curriculum now regarding data and AI. We want to try pushing that. So and I've been asking for this grant to have a bit more possibilities to also do workshops with more colleagues, because many of us do this in different forms, in different ways, have some thoughts about this. If you think of safety and security or about testing, of course, there are many disasters that happen because of software bugs that many of my colleagues have been enthusiastically compiling already. There are many bias and discrimination issues that are quoted in many different courses. So I think even coordinating this a little more and trying to show a little more how this all ties together would help, because you can't, I think we need the ethics course, but not only the ethics course. And because then it becomes a bit too general and you can't apply it to what happens to you in your products. Where at the same time, having one project course also is not enough, because you tried it once on that one domain and you need to start seeing it's everywhere. So we want to make this catalog of what are best practices in teaching this, what works, what's the level of discomfort you can put on your students, because I get lots of complaints in my course that people don't know what I'm asking of them, because I'm asking, like, come with the problem and recommend and explain to me why it's a problem. Yeah, but there's no data. Yeah, where do you get the data then? Oh, it's so hard. Yeah, it's hard indeed. Try it. So this is something really I have to shake them on, which is good. I mean, but it alarms me at the same time that apparently they didn't do that so much yet. So we're now trying to see, like, why is this so? Because many of my colleagues say the same, and then we apparently didn't have room for this. So we try to create it together. We will definitely release material as we go on this. I'm reachable, findable on Twitter and over mail. So please, if anyone watching this also later wants to engage, let me know, because I've just been climbing that soap chest of mine now. But I really hope more people step up here, and we really need to take this very seriously, I'd say.
I think it's really, really good. Yeah, it's really valuable, because otherwise, indeed, we will all end up with this, things with iris, those data set, Mnist hand
Oh.
recognition data set. Like probably there was by the way, there was a picture some time ago that like Godzilla versus King Kong, and it was like titled that Godzilla. It's like. Data scientist resume with Mnist recognition, and versus data science resume with iris in those data sets.
Oh yeah, exactly.
So, and I think right, a lot of efforts are happening regarding, let's say, reviewing the current benchmark data set. It's about, for example, image labeling data sets. It's about as well word labeling data sets. And I think the same story probably in audio labeling and more, because we realize that we optimize everything about the model, especially in academia world, instead of optimizing everything around the data that we have, because the real world will be with this fuzzy, creepy, terrible, noisy data. And you can build in some logic that say, if it's not bright enough, just cut it out. But if all your data will be not bright enough, I mean, like pictures or video streams, whatever you're going to be parsing, then I think it's huge problem, actually. But it's really nice to hear that something will, let's say, will be created, especially to you, Delft, because so far we've seen the most brightest minds coming out from this university. So well done indeed. Okay, so I think probably that's then conclude our session. Nancy, any words from your side?
No, just thank you very much, Cynthia. My headset just ran out of battery, sorry.
That's okay.
So I think we have no questions left in the chat.
Yeah, I just checked it. Yeah.
Okay. So should we close for tonight?
I do hope. Otherwise, we keep talking. It's a really good topic.
We'll close in the stream, people. Bye. Thank you for attending. Happy holidays. See you next year. Take care. Stay well. Aliona and Cynthia.
Happy holidays.
Good evening.